Hello, welcome to the next video. We're continuing with our idea of interpreting data and trying to get some information from it and trying to get ideas of what the spread of data is like, so how consistent it is. And that means we're going to be learning about something called quartiles and interquartile range and semi-interquartile range. Lovely combinations of words. But first off, there's just a couple of definitions we need to make sure we're familiar with first. So, we need to know what the median is, and we need to know what the range means. So median, which hopefully we're familiar with, the median is the middle value when the values are put in numerical order. So middle value when values are in numerical order. We'll go over this in some examples so you fully see what that means, but hopefully you remember. And then the range, that's the difference between lowest and highest values. So if something has a really low range, that means the lowest value and the highest value are quite close together, they're not very spread out. And then if something has a big range, it means they cover a huge distance, so the lowest and the highest values are really far spread out. And so this idea of looking at quartiles and interquartile range and stuff, it's a similar idea to standard deviation. We don't want our views of the average of a set of data or something skewed by one really small value or one massive value. So we more want to look at what's going on in the middle, what's most of the data like. And so let's say then we've got a set of data, and we'll just go with 7 values. Let's say we've got 3, 4, 6, 7, 9, and 11. So first off, our median. So the median is the middle value when the numbers are in numerical order. So these are already in numerical order, and we've got 7 of them. So if we count in from the edge, middle value here is 6. So that is your median. And that's basically what splits it in half. Okay, and so what we want to look at now is what a quartile is. So a quartile, you can think of that like another median, and it's what splits each of these halves in half. And so when you've done your quartiles, your set of data will be split into 4 groups. So splits each side of the median in half. So if we're looking at this information here, we want to split this side of the median in half, and we want to split this side of the median in half. So again, we count in how many numbers we've got. Okay, so the middle value here, that's the 4. So we call this 4 the lower quartile. And then we split this one in half, and we call this one here the upper quartile. And that's how you work out the median, the lower quartiles, and the upper quartiles. It's a really simple process. But what we also want to be able to do is the interquartile range and the semi-interquartile range. So first, the interquartile range. Interquartile range. So that's basically the range, difference between the highest and lowest, but between the quartiles. So it's the difference between the upper quartile and the lower quartile. So difference between upper and lower quartiles. So for this example here, the interquartile range, I'm just going to write IQR because I can't be bothered to write it out. The interquartile range is going to be 9 take away 4. 9 take away 4 equals 5. And so that's giving you a bit of an idea of the spread of the data. And then the last bit we might need is the semi-interquartile range. Semi-interquartile range. And this value is what you would generally use instead of standard deviation. So if you didn't have a calculator, standard deviation can be a bit annoying to calculate without a calculator because it's got square roots in it. So instead, you might try and work out the semi-interquartile range. And the semi-interquartile range is just half of the interquartile range. It's as easy as that. So to work out the semi-interquartile range, it's going to be this, 5 divided by 2. So the semi-interquartile range would be 2.5. And that's all there is to it. So you need to know the definitions. You need to know what your median is and how to get it, and then how to work out your quartiles, and then work out the difference between them. So I'm just going to pause for a second and write down a couple of examples of this to look through. So here the question is asking us to find the median and semi-interquartile range of these two sets of data. So let's have a look at this. Let's start with A. So the first thing we need to do, we need to write them in order, okay? We need to start with the lowest and go up to the highest. So our lowest here is going to be 3. Then we've got 5. We've got another 5. Then 7. Next is 10. Then, 12. Then 13, then 19, and then 20. So to find the median, we're just looking for the middle value. So we'll start at the edges and count in. 1, 2, 3, 4. There. This is the value in the middle. This is a 10. And then we've got 4 values on either side of it. So this here is the median. And so, before we can work out the semi-interquartile range, we need to label the quartiles. And so that means splitting each of these halves in half. So let's start at this one. We want to split these 4, what value is in the middle of it? So we go count in, go in 1, go in the next set. So what's in the middle would actually be here. So this is what happens if you're trying to split up an even group of values. So we've got 4 values here, and if we want to split it up, that means we need 2 on either side. So what we do is we look for the number that's in between these two. And now this is nice and easy, because these are both 5, so that means the lower quartile is 5, because that's what's between 5 and 5. Be a bit different if we go up here. So if we're splitting this one up, we're looking for the middle of these. So we're looking for the value that's between 13 and 19. And so the way you want to do this, little quick way, is to add these up and then divide it by 2. So if we add these up, that gives us 32, and divide that by 2 gives us 16. So the upper quartile equals 16. That's the value that's halfway between 13 and 19. So now I've got these, I can work out my interquartile range. My interquartile range will be 16 take away 5, which equals 11. And then my semi-interquartile range will be half of that, will be 11 divided by 2, which equals 5.5. And there we go. It's as easy as that. The only really time-consuming bit can be writing these out in order, which we'll find out for this one. So for B, let's go through and write them out in order. So it looks like our lowest is going to be 23. So we've got 23, got another 23. I'm not going to talk through this, I'm just going to try and get it done quickly. So these are in numerical order now. So to find the median, let's look for the middle value. So we'll just start at the end and we'll count in pairs till we get to the middle. So So right in the middle is going to be between these two. It's between 27 and 28. Now that's a nice easy one. What number's between 27 and 28? Well, that is 27 and a half. So your median here equals 27.5. And now, you see up on this one, when we were looking for the quartiles, we didn't include that median in it. We were looking for the bits either side of the median. Now, well, there isn't a median in our list. So this is going to be our bottom half, and we're looking to split this up. And this is going to be our top half, and we're looking to split that up. So let's look at here, let's count in what value's in the middle. Well, that's 24. So that's your lower quartile. Then at this side, let's count in. In the middle, we've got 33. So that's our upper quartile. So then to work out our interquartile range, that's the difference between the quartiles, between 33 and 24. So 33 take away 24 equals 9. And then our semi-interquartile range, well, that's just half of that. So that's 9 divided by 2 equals 4.5. And there we go. What you might get asked, however, is to comment on that and say, what does that mean? So you might be given two sets of data. It might be the height of two classes of people. And you'll be asked to work out the semi-interquartile range for both groups. And let's say that this was something like that. And then it will ask you to say, well, what does those semi-interquartile range tell you about the spread of data in those groups? And so what we'd say is, the semi-interquartile range for this second group is smaller than the semi-interquartile range for the other group. So if it's got a smaller semi-interquartile range, it's just like standard deviation. It means they're not spread out as much. The data is more consistent. Okay? And if it's got a bigger semi-interquartile range, it means the data is more spread out and they're less consistent with each other. Right, hopefully that was understandable. If not, you know how to get in touch. Thanks for listening.